guys.
Hey guys, it's Audrey and Emma, and we're Emma and Audrey Evolution. And today it is a Sunday, and tomorrow's Monday, so me and Emma are very sad. But today we will be talking to you about fossil records, carbon dating, and the Cambrian explosion. So today we're going to be talking about fossil records. Well, right now we're going to be talking about fossil records.
Yeah, and then I'm going to be talking about carbon dating, and Audrey's going to finish us out with talking about the Cambrian explosions.
Okay, so as we've talked about, we moved locations because of the crazy neighbors that were talking about weed and were telling us to shut up.
Yeah.
So we moved because we don't want to be in that environment.
Oh,
right?
and I kind of changed into this hoodie and took out my headband.
So that's besides the point. But I'm going to be talking about the fossil records right now. So yeah. So the applicability of the experimental method to the study of such a unique historical process, which basically means fossil records, is very restricted before all else by the time intervals involved, which far exceed the lifetime of any human experimenter. And yet, it is such impossibility that it demanded by anti-evolutionists, which means people that
believe in evolution.
Yeah. When they asked for proofs of evolution, proof of evolution, which they would magnanimously accept as satisfactory. This is about a reasonable.
What?
This is about a reasonable demand, as it would be to ask an astronomer.
The lighting was weird.
Astronomer to recreate the planetary system, or ask a historian to reenact the history of the world from Caesar to Eisenhower.
Dang it. Stop. Oh, shoot.
Well,
I can't do things with my foot.
I just explained it. So we're done here.
Okay. Thank you for watching this part of the video, and continue watching to watch carbon dating and the Cambrian explosion.
This is very interesting.
Hey guys, so you just watched Audrey talk about
fossil dating, fossil recording stuff.
And I will talk to you about carbon dating. Okay, so let's get into this.
Let's get started.
Okay. There are two human activities recognized to have irreparably changed the global radiocarbon levels: the burning of fossil fuel and nuclear weapon testing. Burning of large quantities of fossil fuels like coal, referred to as the Seuss effect, had significantly lowered the radiocarbon concentration of the atmospheric carbon reservoir. In contrast, nuclear weapon testing in the 1950s and 1960s dramatically increased the level of carbon-14 in the atmosphere.
Here's my butt, Emma.
What?
Here's my butt.
Okay,
my socks off. Gosh.
The phenomenon is often referred to as the bomb effect. Stop being like... While the lighter isotopes, carbon-12 and carbon-13, are stable, the heaviest isotope, carbon-14, or radiocarbon, is radioactive. This means its nucleus is so large that it's unstable. Over time, carbon-14 decays into nitrogen, N14. Most carbon-14 is produced in the upper atmosphere where neutrons, which are produced by cosmic rays, react with nitrogen atoms. Radiocarbon dating has transferred our understanding of the past 50,000 years. Professor Willard Libby produced the first radiocarbon dates in 1949 and was later awarded the Nobel Prize for his efforts. Some have suggested that the rate of decay of carbon-14 has changed in the past. However, the evidence is very strong that as far as we know, the half-lived has never changed. So the first assumption is very strong. The third assumption is also reasonable. If any animal or plant is living on the surface of the earth, it will be taken in food or CO2. Thus, there should be a full exchange of carbon with the environment. The fifth assumption is one that scientists are doing their best to fulfill. We should also be able to make this assumption. However, machine background has become a very important factor to consider. So there you go. That's just a little information about carbon dating. If you are interested, you can research it some more yourself.
Okay, guys, so Emma just talked to you about carbon dating, and now I want to be talking about the Cambrian explosion. So the Cambrian explosion, or Cambrian radiation, was the event of approximately 541 million years ago in the Cambrian period, when most major animal phyla appeared in the fossil record. Phyla appeared. Whatever, same thing.
Okay.
It resulted in divergence of most modern metazoan phyla. The event was accompanied by major diversification of other organisms. Before the Cambrian explosion, most organisms were simple, composed of individual cells occasionally organized into colonies. Over the following 70 to 80 million years, the rate of diversification accelerated, and the variety of life began to resemble that of today. Almost all present animal phyla, same thing, appeared during this period. Or, this basically all means, before this explosion, all living organisms were simple, as in the organisms were made of individual little cells, and sometimes many of them referring to colonies. With the following 70 to 80 million years following, the organisms shifted to be more like the current ones today. The Cambrian explosion is believed to have a great impact on living organisms today. So the seemingly rapid appearance of fossils in the primordial strata was noted by William Buckland in the 1840s. Or basically what that means is, when the fossils were found, it was clear that the earlier species were starting to change. This was interesting to William Buckland. William wrote a book on what he thought or think caused the rapid change of the organism. He believed that this was because of natural selection, which we talked about in our earlier video. Because as the environment was adapting to the genes needed to survive in the area, those would survive better than specific animals that didn't have genes to benefit them or help them thrive in their environment, if in any way, would get killed off easier because they were not fit to live in that specific environment. Yeah.
Good job. Are you done?
Bloopers.
Thanks.
Okay.
Wow.
Thanks.
Okay.
Thanks for watching, guys. I hope you enjoyed those videos, and if none of that made sense to you, just click the link below. The link will be linked to a doc that we have below. So, yeah, like and subscribe.
And watch our other videos to learn more about evolution and interesting stuff like Charles Darwin and
that stuff. So,
embryology.
Yeah. Bye.
Bye.